Hello, chemistry. Mr. McKee here. Happy Friday to you. You are going to be doing a lab today, and I'm obviously not present, so I wanted to give you some notes here to help you be successful. So first of all, the lab is on pages 62 through 68. We're not going to do all those pages today, though. Today on Friday, you're only going to be doing pages 62 through 64. Our ultimate goal as of Monday next week is you're going to use the property of density to determine the identity of an unknown metal. Furthermore, you're going to be practicing something we've been talking about, making precise measurements and making calculations with the correct number of significant figures. And ultimately, this is what your group is going to be evaluated on. So I'm going to be checking your data to make sure that it is correctly and precisely gathered. So please make sure that you understand how to do that. I'm going to walk you through some of this stuff right now. Your group is going to be given 5 samples. Those samples will be labeled A, B, C, D, and F of some unknown metal. And it's going to be the same metal for all of those samples, but they're going to have different sizes. And around the room is 8 different boxes of metals. And they're numbered 1 through 8, and they correspond to your normal lab group. So if you're in lab station 1 normally, you're going to have metal number 1. And you're not going to know what metal it is. That's the whole point here, is you're trying to figure that out. And we're going to end up doing that on Monday, but you're going to start the process today on Friday. Okay, as I said, you're just going to be measuring the mass and volume today on Friday. And you're going to be completing pages 62 through 64 only, and I'm going to walk you through those pages now. Please take note as I walk you through this. There's some important details here if you want to get full credit for this lab. So part 1 is measuring mass, and this should be pretty straightforward because you're using the balances. Remember, in order to use the balance successfully, hold down the 0 button until the balance comes on, and then you can press the button again to 0 it out. It should read 0. And then you can start measuring the mass of each of your samples. Our balances are precise to the hundredths place. So everyone should have for their samples to the hundredths place. For example, 55.67 grams. If someone in your group has 55.6, then they've done it incorrectly here. Okay, they've for some reason dropped that 7 off, and we don't want to do that because that 7 is estimated. Remember how we record things. We list all known digits and then 1 estimated digit here, but your balance does that for you. So if you just write down what is on the balance, you should be good there. All right, so let me show you what your data should look like for masses. Here is a hypothetical group consisting of Tim, Jose, Damien, and me, Joel. Okay, we should have pretty similar measurements for piece of metal A. We're all measuring the same piece of metal, and the digital balances kind of take the difficulty out of this. So notice we do have pretty similar measurements here, and notice that we all have to the hundredths place for our data. And again, this is for metal sample A. And this is box number 7. So after we do this, I'm going to calculate the average for the 4 people in the group. You might only have 3 people. We do the same thing. To calculate the average, we add up all of these masses, all 4 of them, and divide by 4. And in this case, when I do that, I get 30.54 grams. That's my average mass. Then we're going to repeat that for samples B through E, okay, which are going to have different masses because they're going to have different sizes in most cases. Okay. Moving on to the second part of the lab, the volume measurements. This is going to be a little more tricky because we don't have a digital instrument that can record the volume for us. We're going to have to do things a little more old school. So I'm going to walk you through that here. And you should draw pictures and take notes because this is the part that can be easily messed up if you're not careful. So here is the basic process. You're going to be using a graduated cylinder. That is these things that I've drawn up here. Those are around the room in each group. And what you're going to do is you're going to put some quantity of water, usually about halfway full for the graduated cylinder, is going to be sufficient. Doesn't really matter how much you have, but you should record this as the initial volume. In this case, it's 61.5 milliliters. If you have 70.3, if you have 45.6, that's fine. Just make sure that your piece of metal can be fully submerged under the water, okay? I'll explain more about that in a second. The other thing to notice here is that our graduated cylinders are precise to the tenths place. So you shouldn't tell me that it's 61 milliliters for the initial volume. We know, we should be able to tell for sure that it's 61 point something. So we're going to estimate our final digit, the tenths place. So you should have a measurement with 1 decimal place, in other words here, using these graduated cylinders. Okay? So I just have water here. The initial measurement is 61.5. Then I'm going to add my piece of metal to the graduated cylinder, and you can probably predict that the volume is going to go up because the water is being displaced by the piece of metal, and we want to make sure that the metal is fully submerged here, and you want to do this carefully so that you don't lose any water when you put it in there. You don't want to splash it because otherwise that can affect the precision of your measurements. And the basic concept here is the amount that the volume changes is going to be exactly equal to the volume of the metal object. So the volume in this case goes from 61.5 to 81.5, and we can do some subtraction down here. And in this case, the change in volume is 20.0. Notice that I put that 0.0 there because that's the precision that we're working with here to the tenths place using our rules of significant figures. So I just calculated the volume of this piece of metal to be 20.0 milliliters. So let's go to our data table now. All right, in this case, for some reason I put a different volume on here, but you can ignore that. But here's some other hypothetical data. If my initial volume was 56.7 milliliters and my final was 90.2 milliliters, then the volume of my sample would actually be 33.5 milliliters. Again, notice that all these are rounded to the tenths place, as they should be. And every other piece of data should also be to the tenths place here because that's the precision that we can get with these graduated cylinders. I'm going to repeat that. Notice that table 2 is for just me. So I'm going to do the same thing for metal sample B, C, D, and E here. And I'm going to fill out this data table. Everybody in my group is going to do the same thing. And we want to do this independently because we're trying to corroborate data. If we just copy each other, it's pointless. So each person in the group is going to do this on their own, independently, and fill out data table 2. Then we're all going to put our data together. Tim is going to list his volume. Jose is going to list his volume. Damien's going to list his, and I'm going to list mine. All right, when you look at this volume, something should stand out to you. If you understand what's going on here, it should be fairly obvious that Damien screwed something up here, all right? For one thing, his precision is off. He does not have a decimal place here, so that's a problem because we should all have volumes to the tenths place. Also, his is quite a bit different than all the rest here for the volume. So Damien should redo this, should consult with his group, and make sure that he figures out the mistake that he makes. All right, and it's fine to redo stuff here as needed. Check in with each other. That's the point of science. That's why we compare data. So we're going to continue to do this for samples B, C, D, and E. Again, we'll calculate the averages over here when we're all done for each piece of metal. Again, the way to get average, and you can Google this if you need help, but you add all of the samples together and then divide by 4. That changes if you only have 3 people in your group, of course. Divide by 3. Okay, that's table 3. And that concludes what we're trying to do on Friday. Again, I can't stress enough, pay attention to precision and significant figures. Follow all of these instructions and have a great day. Email me if you have any questions.